is we out for lunch. Okay, so then let me check. If I'm going to cut the short break, so yeah, it's possible. So it is sample short break, but ending the training longer. Yeah, so it'll be up to you again. So I think it should be okay. So maybe today we just move all the short break to for the lunch. Okay. So then by this 11:30 go for lunch and then return at 2 like this. So I will going to cut off the short break. Okay, so then you guys can have a longer time for you to go out for pray and also enjoy your lunch. Of course, you also can get some rest. So everyone also agree? Yeah, so if no objections, then I will just follow this timer. So 11:30 go for lunch. Then we'll come back and continue the training at 2 p.m. Okay, I hope everyone can able to hear my voice. Because today I try to using my mic here, okay, the headset, because it's using the laptop, the speaker, they actually use the very high the CPU utilized. So I try to using the headset, see whether the effect better or not. Okay, so now we're going to start the training. Okay, so on the yesterday that we already showed the VLAN configurations. So today is also a part of the VLAN. Okay, this time the VLAN is actually showing us how to perform the routing between the VLAN. So even that you are using the different VLAN, okay, but you still can able to ping to another VLAN user. So first you have to understand, right, why we need to have a VLAN. Okay, the reason we're using a VLAN, okay, the background here got mentioned. In real world, the network deployment, different IP address segments are assigned to the different VLAN. Okay, so this is the design. Okay, normally kan satu VLAN, dia ada sendiri punya subnet. Okay, kalau multiple VLAN kan, that means dia pun ada multiple punya subnet. The PC on the same network segment in the same VLAN can directly communicate with each other without the need of the layer 2 device. So, kalau within sama punya VLAN, sebenarnya mereka tak perlu ada itu layer 3 punya equipment, tak perlu, terus piping. So, semalam saya pun sudah tunjukkan PC 1, 3 dan 5, semua PC pun boleh ping sebab mereka di dalam VLAN yang sama. So, this communication mode is called layer 2 communication. Kita cakap ini ialah switching. It is layer 2 switching. Inter-VLAN communication belong to layer 3, so which require the layer 3 equipment. Kalau you pakai hanya satu switch saja kan, ini memang tak cukup punya. Sebab switch kan, dia hanya boleh tolong kita buat itu switching. Okay, layer 2 punya communication. So, the reason we using the VLAN, apa sebab dia? Kita nak kurangkan itu broadcast down. Okay, macam ni. Kalau PC 1 daripada VLAN 10, ia sehingga itu broadcast kan, ia cuba hantarkan broadcast. Itu broadcast kan, hanya boleh masuk balik ke sendiri punya VLAN saja. So, itu broadcast, dia tak akan masuk ke lain punya VLAN. So, this is the reason why we use the VLAN, to reduce the broadcast. Okay, so you also can imagine for one of the campus university, the college, they got so many of the students, okay? So I think that few thousand, 5,000 or 10,000, who knows? So if all the students, of course it's not all the students, so if let's say everyone want to connect to the network, the internet, okay, the campus network, they want to join the Wi-Fi. So everybody is actually connected to the internet and they want to browse the network. So do you know when the PC join the network, right, they will send the broadcast periodically, no matter you want or don't want, the ARP will be sent. So if they never using the VLAN to isolate the like example, the instructor, the teacher, and the student, right, what will happen? The student broadcast will be actually go to the lecturer side, okay, the instructor or maybe the teacher side. So those broadcasts, right, will slow down the lecturer, the internet experience. Okay, will be actually very bad. So that's why normally, right, the engineer will try to design the lecturer, the teacher have one VLAN, then the student have another VLAN. So no matter how heavy of the student broadcast, the broadcast won't go to the lecturer side. So to help to save the lecturer bandwidth. Okay, so this is a main purpose to create the VLAN. So after we already create the VLAN, then they have another issue now. So if they belong to the two different VLAN, so maybe for the student, right, they also got different VLAN. So one is actually for the size, yeah, another maybe for some of the experiment, or maybe some is for the online project, online studying. So they actually all under a different VLAN. So when you put the student using a different VLAN, right, the second problem comes is they cannot form any communication. So if you are allowed the student to communicate, even they are belong to the different VLAN, all right? So you need to have a layer 3 equipment. Can be the firewall, can be the router, and also can be the layer 3 switch. So it depends on how you configure that. So common layer 3 device, macam tadi saya cakap lah, router, layer 3 switch, atau firewall pun boleh. Interval communication is implemented by connecting a layer 2 switch. Ini ya layer 2 switch, semua layer 2 punya LAN port. So to a layer 3 interface router. Okay, the communication packet are route by the layer 3 device. So router ini akan tolong mereka perform routing. So you daripada VLAN 10 kan, okay, you akan hantar itu packet ke saya punya tempat. Okay, you hantar ke saya punya tempat. You just send to me, and then right from here, I'm going to help you to change the VLAN, send to the VLAN 20. So the router will actually help you to change your VLAN. You are not supposed to go to the VLAN 20. If you want to go to the VLAN 20, you have to change your tag. So that's why router dia tolong tukarkan VLAN tag. Okay, so this process is called VLAN routing. Okay, VLAN routing. Okay, now using a router, okay, there are other dua contoh. Contoh pertama yang physical punya, yang contoh kedua sub interface. Dua-dua pun boleh achieve inter VLAN communication atau kita panggil VLAN routing. Okay, so using a router physical interface. Kalau sekarang kita gunakan physical interface to perform the routing kan, macam mana kita buat? First, kalau PC satu ini di dalam VLAN 10, okay, VLAN 10. So you need to configure your IP in the VLAN 10 and your gateway. Sama subnet lah. You nampak dua ini ya sama subnet. Okay, so ini .254 kan. This is the gateway. You be configured on the router here, one of the interface. PC2, the gateway is also one of the IP on the router 1 here. Okay, another interface. So that means satu VLAN, you perlu reservekan at least satu port, okay, di router sini. Kalau you ada 3 VLAN kan, you perlu configure 3 port. Alright, so based on the number of the VLAN. So now VLAN 10 punya traffic kan, dia akan masuk ke port sini. Then after dia sudah tukarkan you punya packet akan hantar dari sini pergi ke PC2. So guna cara ini kan, you boleh communicate dengan VLAN lain. So this is called the VLAN routing. Tapi ini cara dia kan, ada satu weakness. Okay, dia punya weakness ialah apa? Kalau sekarang you punya network kan, you got many of the VLAN that you want to configure. So you got around like 10 VLAN, 20 VLAN. Oh my God, 20 VLAN. Okay, so that means your router right here, you also need to get ready. You got 20 VLAN. I mean, bukan VLAN, 20 port, 20 port. So itu port punya number kan, equal dengan you punya number of the VLAN. VLAN that you configure in your network, more port you need to configure on your router. Tapi bukan semua router ada 20 port. Okay, so that's why ini cara dia kan, dia ada satu kelemahan. Itu ialah dia tak boleh buatkan itu network kalau dia ada banyak VLAN. So this kind of the implementation is only suitable for small network when the VLAN is not so many. Okay, so ini solution yang pertama. Okay, yang kedua macam mana dia buat? Yang kedua kan, okay, PC pun sama, mereka ada sendiri punya gateway, sendiri punya VLAN, tapi when the switch connect ke atas itu router kan, dia tak perlu pergi standby banyak interface. It's not necessary. You saw that this is actually just one interface, satu sahaja. Tapi nampak itu port ini gig 001.10. Ini gig 001.20. Sebenarnya dua-dua interface ini pun asal daripada port nombor 1. It still is a port number 1. Ini sebenarnya port number 1 is only one interface saja. It's just one interface. Tapi ia kasih asingkan dua. This is the sub interface. So dua sub interface ini sharing the same port. Okay, sharing the same port. Ini cara dia kan. You boleh support lagi banyak punya VLAN. Itu sub interface you boleh create up to 4,000. 4K is quite a lot. So ini kan you tak perlu pergi risau tentang port punya problem. Okay, no need to worry. So even you tell me that you got 40 VLAN in your network, not a big deal. Okay, by this interface I can create a lot of the sub interface. Tapi kan ini cara dia ada apa kelemahan. Tadi punya physical interface okay, let me show you previous one. For physical punya satu VLAN, satu port. So ini akan costkan port limitation. Cara kedua. Okay, sekarang kan kita sudah tak ada masalah itu port punya masalah kan. Sebab kita boleh gunakan sub interface. But you are facing another problem. Another problem is what? Now, everyone is actually sharing the same port. That means the bandwidth also we're going to share. So semakin banyak VLAN you configure kan, then more bandwidth will be shared. So supposedly you can get the full speed. Tapi sekarang kan, sebab semua orang pun share sama punya gateway kan, sama punya port. Then the bandwidth pun akan share juga. So all of your user, right, you can't able to get a high speed or full speed anymore. Okay, ini adalah mereka punya masalah. Okay, so that's why you have to concern that which solution is the best for me. Okay, I cannot say which one is better. Okay, it depends. Okay, depend on your network design, the network scenario. So whether you are suitable for just now the physical configuration or the sub interface. Okay, you can use either one. Yeah, the sub interface processing. So dia cakap sekarang PC sini kan, dia VLAN 10, ini VLAN 20. Then PC1, this traffic they actually send to the port here is a VLAN 10 using a trunk link sent to the port number 1. This is on the router. So then they actually will perform the VLAN swap. Dia akan tukarkan VLAN, lepas keluar dari sini, you jadi VLAN 20. Hendak ke port sini, pergi ke PC2. Sebab dia tolong you tukarkan itu VLAN di tempat router. So this one is using a sub interface. Okay, based on the VLAN ID carrier in the packet, excuse me, the device forward the packet to corresponding sub interface. So through the sub interface, the device can implement the Intervan commission at the layer 3. Okay, so yeah, this is just a repeat stuff. Dia tolong you buat itu routing di router. Okay, sekarang dia tunjukkan itu cara. Okay, I will just show you the lab guide on my ENSP. Okay, I will show you the result also. So now, Ini kan yang semua buat punya, saya semua kasih turunkan. Yeah, I don't need this one anymore. Some space. Don't worry, this one I will also share to everyone once already done. Which one? Oh, this one first. We are router one. Okay. Boleh. Ini display kemana? Ini boleh kita ke sini. What I'm going to do now here? Let me see. If I want to create, okay, kita keluarkan satu router dulu, one router. Okay, ini router kan saya akan guna for routing. Okay, for routing. Sepuluh suatu nah. Nah, okay. 11 2 and then 12 12 to port number 2. Okay, like this. Port 1 and port 2. Okay, because I want to do the VLAN routing and my network is for VLAN 10, another one is for VLAN 20. So ini cara for physical interface punya VLAN configuration. Okay, port 1, port 2. Then the switcher is 11 and 12. Okay, for number. So I bring a configuration the switch digger. Okay, saya letak switch digger. Switch 3. Interface gig 0011. Okay, this is my switch tree configuration. Mengapa saya perlu buat macam itu kan? Sebab sekarang router hanya tolong buat routing saja. Dia tak tolong you buat itu itu tag punya label. So biasakan itu VLAN punya tagging kan buat di dalam switch. Okay, switch hanya switch boleh faham. So that's why the switch right here, the two interface, port 11, you know, okay, port 11 ialah VLAN 10. Then port 12 belong ke VLAN 20. So that's why we have to do this one on the switch. Kalau sekarang kita pakaikan physical interface to perform the VLAN routing. Okay, on the R2 sini. Okay, ini ya gateway ya. Okay, R2. And this is my R2. Okay, R2 and the switch tree. Okay, I bring configurations. Tapi di sini kan semua PC ya, you nak kasihkan gateway for America. Okay, all of these PC you have to give the gateway. Okay, semalam saya dah buat ini. So you have me to configure this one. We start it. Here, 10.1.1.2.5.4. 10.2.2.2.5.4. 2.5.4. Make sure all you already configured the gateway. Okay, sebelum tu kan, saya nak prove dulu I'm using my PC1 ping to the PC2. Okay, PC1 ping to PC2. So I try this command I put down. Okay, PC1 ping to PC2. 10.2.2.2. Okay, saya belum configure lagi so that's why I just want to prove right. Now the two different VLAN they cannot form any communication. Kalau I gunakan PC1 kan, I only can ping to my same VLAN user saja. Example 3 boleh. Okay, then 5 pun boleh. Yeah, so this is how it works. Okay, so 1, 3, 5 kan, yang ganjil punya nombor semua boleh ping sebab VLAN 10. Tapi untuk genap punya kan, itu 2, 4, and 6 tak boleh sebab VLAN tak sama. So now, if I'm going to configure this one on my router, okay, senang saja, saya copy and paste. So now one interface, one IP address. So see the result. My PC1 okay, tadi saya cuba ping ke PC2 10.2.2.2. Okay, again see the result. Aha, dia dapat reply. So sudah berjaya. So kalau ada router tolong performkan routing sangat senang. So even you are belong to the two different VLAN, you have no issue to form the communication. I want to ping to PC4 pun boleh. Okay, boleh begini. What I think go to the PC6. Boleh. Okay, so this is the VLAN routing. So now, no matter you are the VLAN 10 or VLAN 20, you can form the communication. Tapi mereka punya traffic flow tak sama. Sekarang, kalau gunakan VLAN 10 kan, VLAN 10 punya traffic akan tak lalui macam ni. Okay, dia pergi ke asal 4, sudah lebih. So tadi a bit lag. So dia akan mark begini. Ini ya layer 2 punya traffic. Okay, layer 2 punya traffic. Sama VLAN ya layer 2. Tapi kalau PC1 nak pergi cakap dengan example PC4, okay, PC4. So dia punya traffic kan, dia akan lalui switch sendiri, pergi ke switch kedua, switch ketiga, pergi ke router, pergi ke sini. Okay, and then router here will actually help to actually change like perform the routing dia tolong perform routing sebab router sini ya gateway kan sekarang you sudah sampai sana dia tolong you gunakan IP address yang lain keluar dari sini sudah route masuk dari port yang 12 okay, lepas tu pergi ke PC4 so ini adalah layer 3 sebab you performkan routing so kita punya traffic flow ada sedikit tak sama punya if you are under the VLAN yang summer, you're under the same VLAN, so you can actually using a layer 2 connection direct. But once your subnet or your VLAN is different, so you have to send your traffic all the way to the gateway. Kita punya gateway di router sana. So that's why when the router receive your packet, right, you have to perform the routing. Okay, so you boleh nampak dia keluar daripada port 11. Dia tahu you gunakan VLAN 10. Dan lepas tu dia masuk balik ke port 12. Kalau dia masuk ke port 12, you nampak port 12 ya VLAN 20. So itu VLAN punya tagging kan, dia port di mana? Dia bukan port di router. Sebenarnya dia perform di switch. Nah, switch boleh faham VLAN apa. Okay. VLAN 10 keluar daripada port 11 dan itu paket masuk balik ke switch lagi kan di port 12. So guna cara ini kan dia boleh tukarkan itu VLAN tab, okay, to form the communication. So ini adalah cara yang paling pertama for the physical layer VLAN communication. Okay ya, so kalau ini sudah, I'll try to show you the next one. Okay, yang seterusnya. So seterusnya, okay, ini adalah option nomor 1 lah. Okay, option A. Sekarang saya tunjukkan option B ya. Option B. Guna port nombor 3. Wah, tak nampak ni the port. Okay, so 1, 2, 3. Okay, don't worry ya. Dia sedikit messy dekat sini. So port 3 connect ke port 13. Okay, port 3 ke port 13. So now what I'm going to do, okay, ini for option A ni ya. Try to don't mix up option A ni ya. Saya没有switch ada masalah. Okay, I'm going to move this away. Option A ni ya. So kali ini saya buat option B. Okay, switch 3. Interface G0013 top lane. Okay, this is the second option, option B on the switch tree. Saya buat apa? Name. Saya copy paste yang salah punya. Ayah, name switch tree. Okay, then ini saya perlu copy lagi. Okay, then this is the correct one. Okay, so this is my switch tree. So kali ini ya, I tak gunakan access lagi. The option A kan, these two interface you need to using the access port. But now I will using the sub interface. Cara kedua. So now my port number 30, I will use the trunk. Okay, saya guna trunk. G001. Sekarang ya router 2. 2. Okay, guna command ini untuk resetkan itu configuration dulu. Okay, create configuration. So, kalau you sudah gunakan itu command kan, then number 2 ini sudah shut down. Switch number, the lookout is 0. Display interface brief. This is up. 11 and 12 is down. Oh, betul lah. 11 dan 12 betul lah. Sebab saya pergi shutdown-nya. Sebab saya bercommand yang macam tu. Kalau you sudah shutdown kan, you sudah clear kan itu configuration, you to port akan shutdown. Okay, port akan shutdown. So this is another command. Ini sini ada sedikit messy ya. 13 di atas, 11, 12 di bawah. 13 di atas. This is port 1 and port 2. Hard to see. Okay, should be like this lah. Ingat lah, ini yang Huawei punya command. When you already do a lot of configuration on that interface kan, tapi you tak mau pergi delete kan one by one. Because if you going to delete one by one, it's just wasting your time. So Huawei ada ini command, clear configuration interface. So apa command yang you ada buat di dalam itu interface kan, semua akan clear. Okay, after dia clear, let me show you. Interface G001 sini kan, sekarang dia hanya tunjuk apa? Shutdown. Okay, after you clear the command, itu interface akan auto shutdown. Okay, but don't worry ya. Anyway, I'm also not using this two interface already. Okay, I tak guna. I sekarang guna port number 3 di router dulu. Okay, now saya punya configuration. Interface G003.10. This is a sub interface. .1Q termination VLAN ID 10. Nah, support layer 2 punya broadcast. Okay, IP address 10.11254. Macam ni. Untuk VLAN 20, this is the IP. Okay, my configurations. Option B on the R2. Okay, so okay, this is the sub interface configuration. Kali ini kan, switch dia tak buat itu tagging lagi. Okay, yang sebelum punya option A kan, switch kita akan tolong buat itu VLAN punya relabel. Dia tolong you tukarkan itu tag. Tapi kali ini ya, switch dia tak buat apa-apa. Switch dia cakap, okay, saya cuma ya trunk. Okay, apa VLAN yang saya dapatkan, I forward saja. Dia kasih semua VLAN forward ke router. So router sini kan ada sub interface. Okay, the sub interface. So the router you perform the VLAN tagging on the sub interface. Kali ini ya router dia buat. Sebelum tu ialah switch dia buat VLAN routing. VLAN punya tagging lah. So now the PC1 kalau nak check out dengan PC 4, okay. So dia akan send pergi ke router sini. And router sini after tukarkan itu VLAN tag, dia akan hantar ke line punya VLAN like this. So option A, okay, option A ya, VLAN tagging dia buat di sini. Okay, I mean the option A. Option A punya VLAN tagging di switch. Option B, VLAN tagging dia buat di dalam sub interface. Di dalam sub interface. Ada differentnya. So, kalau itu router punya performance bukan sangat bagus, you boleh gunakan cara pertama. Option A. Biarkan switch performkan VLAN tagging. Jangan gunakan router. Okay, if your router performance is better than the switch, you boleh pakaikan router perform the VLAN tagging. Okay, so this is option 1, option 2. Okay, you main nampak? Okay, sekarang I try first. Tengok boleh tak? Sebab tadi saya short out 2 interface kan, 1 and 2. 1 dan 2 pun tak boleh guna sekarang. Okay, now, you see the PC1 can still ping to the PC6. Tak ada masalah. Okay, still boleh. Yeah, no issue. So this is my the VLAN routing configuration. Option A and also the option B. Okay, so I hope all of you can manage to do this one. Tak sangat susah punya. Yeah, so far I only show you this switch and the router configuration. Okay, kalau tak ada problem kan? Okay, here is all done already. Then the next one. Using VLAN interface to implement inter-VLAN communication. So ini ialah option ketiga. A layer 2 switch provide only layer 2 switching function, but we can actually using a layer 3 to perform the VLAN routing as well. Selain daripada VLAN routing di router kan, switch pun boleh buat VLAN routing. Okay, tapi kan dia perlu layer 3 punya switch. VLAN IF is the interface. Okay, VLAN if interface is the layer 3 logical interface that can remove and add the VLAN tag. So VLAN interface therefore can be used to implement inter-VLAN communication. Ini cara kan lagi senang kalau you pergi cuba compare dengan tadi saya tunjuk punya option A, option B. Okay, lagi senang. Kita hanya buat di dalam switch sahaja. So sini dia tunjukkan example configuration. Let me show you my options C. Kali saya tak perlu ini lagi. Hot 13. Saya create itu configuration dulu. So after create, you nampak sini punya connection semua sudah cut off. It is already shut down. So now, after the link is already shut down, my PC1 they cannot ping to the PC4, PC6 anymore. Sebab tak ada gateway lagi. So since they have no more gateway. Now the routing cannot be performed. Sekarang, macam mana option C buat? Okay, option C punya cara yang ni. Okay, settle. And this is the option C. You tak perlu langsung pergi ke port sana kan, configure VLAN port link type. Okay, tak perlu. Tak perlu configure access port, tak perlu gunakan trunk link. Sebab sekarang routing kan, dia perform di switch sahaja. Perform di switch sahaja. Tengok adakah sekarang PC sudah boleh ping ke VLAN lain? Tadi tak boleh kan? Okay, saya ping ke PC 4 sekali lagi ya. Ping. Sekarang boleh. Okay, I'll try to ping to the PC 6. Yeah, no problem. So this is my option C configuration. Lagi senang. Okay, we can do this VLAN routing right on the switch, layer 3 switch. So this is a 3 options for the VLAN routing. Okay, mana-mana satu pun boleh punya. Okay, depend that which one that you feel is more convenient for you to implement it in your network. So maybe just give you a guess. Okay, after I show you the 3 options, option A, option B, and the option C configuration. So which one that you feel the VLAN routing is the most common used VLAN routing? Yang top pilihan punya. Do you know which one? Okay, mana satu? You can try to guess. Okay, we got so many ways to perform the VLAN routing. Tapi mana satu ialah the top punya, the most common use. Yeah, just want to see that how many of you know about the answer. Option B. Option B ialah sub interface. Option A ialah pakai physical interface. Option B ialah pakai sub interface. Option C ialah layer 3 switch. Yeah, just want to see that how many of you know about that. Yeah, ada pernah configure ini tak? Okay, not necessarily to be the Huawei device. Okay, can be any hardware as well. Layer 3 interface, option C. Okay, layer 3 switch. So the rest one is IDK. Is it? So I guess You know what's the IDK? I don't know. Okay, so the rest one. Okay, so I read the answer. The answer is option B. Okay, option B adalah jawapan. Okay, I'm going to explain why. Draw here. Okay, VLAN routing. Okay, dia ada 3 option. Saya perlu draw dia keluar dulu. Wait. There is sometimes a bit. Okay, so the connections. Sebab tadi saya ada tunjuk 3 contoh. Routing. then this is the VLAN routing. Okay, so saya sudah tunjukkan semua dia punya advantage dan also disadvantage. So you boleh nampak di sini ya, option A dia ada satu switch dengan gateway. Saya letak gateway ya, saya tak cakap ini ya router ke apa-apa. So saya namakan ia ialah gateway. Okay, gateway ini boleh ialah switch, boleh ialah firewall, server atau router. Okay, so ini paling penting kita faham. This is the gateway. Connect now. The option A ya, routing on the physical port. Each VLAN require one interface. That means kalau ada 10 VLAN, you perlu standby 10 interface. Then you akan ada banyak VLAN, you perlu ada banyak port. So mana ada router kan boleh support banyak portnya. Most of the router right is only few port. Okay, unless you buy those of the mid-end atau high-end punya router, baru ada banyak interface. Or else standard router hanya 4 to 8 port saja. Okay, 4 to 8. Then for option B punya cara bagus sikit. Routing on sub interface. Ramai orang panggil ini ialah routing on the stick. Mengapa? Sebab dia pakai satu interface connect saja. Routing on the stick. So dia boleh solvekan port limitation punya issue. Sekarang kan, you boleh pakai 1000 punya VLAN pun tak apa. Sebab I pakai satu interface boleh support semua. Tapi apa masalah? Bandwidth limitation. Mengapa saya cakap bandwidth limitation? You boleh imagine sekarang, you ada 100 VLAN. Tapi 100 VLAN share sama punya port. Sharing satu port. Kalau ini port hanya 1 gig saja kan, you ada 1000 VLAN atau 100 VLAN akan bahagi. Okay, you going to share the same bandwidth. So ini ialah dia punya masalah lah. Tapi ada solution juga. Okay, ini solution di sini ya. Sebenarnya mereka cakap. Okay, don't know how many of you know about this one. Gunakan LACP. Okay, some guy who actually implemented this one before, I think you should know. Apa panggil LACP? Link Aggregation Control Protocol. Dia bila masuk ialah, you boleh bergabungkan multiple interface kan. Macam saya sekarang, saya nak gunakan 2 interface. Okay, lepas tu kan saya enable LACP. 2 interface ini ya, dia akan jadi satu logical port. Logical. 2 physical, tapi after you enable kan, 2 ini akan combine jadi satu. So, 1 gig punya port sekarang jadi 2 gig. So, ini ialah macam bergabung punya teknologi lah. You can actually bundle 2 interface become 1 to increase the bandwidth. Okay, ini adalah satu contoh dia lah. So, ini adalah satu sebab mengapa ramai orang suka nak gunakan routing on the stick. Sebab ini bukan masalah lagi. Dulu mereka memang complain kan, itu bandwidth ia sharing dia. Tapi kan, kita boleh gunakan LACP, solvekan itu masalah, increasekan bandwidth. Okay? Okay, option C. Ramai orang ingat kan, option C ialah jawapan. Okay, ini memang betul lah. Tapi kan, in the live network, tak banyak company akan gunakan option C. Hanya company yang kecil saja. Only for the small company and then no concern on security. Mengapa? Sebab, okay, routing kan, dia buat di dalam switch. Okay, so dia tak perlu router, tak perlu firewall. So that means itu traffic dia sebenarnya boleh bypasskan firewall. So sekarang kalau saya nak buat routing kan, dia boleh terus route macam tu saja. Walaupun okay, you ada firewall dekat atas sana kan, you ada firewall. Firewall dekat atas ini. Okay, you boleh tambah apa-apa rule di dalam. Okay, tapi no use punya. Sebab kan you cakap, oh di firewall sini saya tambahkan rule. Saya nak block VLAN 2 pergi ke VLAN 3. Okay, you saya tambah rule ini kan. Tapi kan, mana mereka tak care punya. Sebab kan, yeah, I not even need to go to firewall. I can talk to the VLAN tree already. Okay, so no matter you're going to add the rule in the firewall, dia tak boleh block punya. You masukkan MAC address ke, you masukkan IP dia tak kisah. Because we don't need to go to firewall. Mengapa saya nak pergi ke firewall? You pun tak tolong saya buat routing. Saya hanya perlu switch saja. So that's why saya letak ini. Security risk. So most of the company, right, even for the campus, the network like school, the university, right, college, mereka pun tak suka guna ini. Okay, sebab it's dangerous. So if you know about this kind of concept, the VLAN routing, I will suggest not to use option C. Bukan tak boleh, boleh, tapi you nak faham mengapa you nak guna ini. Okay, then you use that. If you consider about the security risk, kan, better to using the option C. You boleh go for option A, option B, but seldom go for option C. Pun ada orang gunakan option A punya. You cakap tak ada, memang ada punya. Sebab ada some of the company, right, they want to have a dedicated bandwidth. Setiap satu VLAN kan, mereka punya itu bandwidth fix di 1 gig. So that means you punya traffic 1 gig all the way pergi ke atas. Lepas tu dia download speed ke lain punya tempat pun 1 gig. So dia tak mau share punya. Semua VLAN pun ada 1 gig punya full speed. Then dia akan pakai option A. Okay, so it's not jangan cakap option A tak ada orang pun pakai ya. Data center ISP pun mungkin akan pakai dia because they need to have a high speed connection. Okay, they need that. So, and these 3 options, right, is good for you guys to understand because, right, different scenario, different application, they have a different requirement. So sometimes the customer, they don't agree the option B. So dia cakap, I punya company pun tak perlu gunakan firewall punya kan. So it's just a small company. I subscribe the internet daripada ISP. Dia kasih I satu modem, satu Wi-Fi router kan. Okay, itu sudah cukup kan. I just want to go to internet online. And my office is just a small office. The staff is only like 10 employee. Tak banyak, 10 employee saja. So tak perlu firewall. Okay, so I hanya perlu ada satu switch boleh support multiple connection. That's all. Can you help me to do the routing on the switch? Then pun ada company pakai option C juga. If the network is not concerned about the security, you can go for that. Okay. Tapi kalau concern about security, you boleh gunakan cara ini atau cara ini. Okay. Sebab itu traffic mesti nak lalui firewall. Yeah, except this one. And this one, I also need to save it. Okay, let me make a copy first. Okay. Tekan mana? VLAN hybrid. This one. Okay, I'm going to upload to my drive. I share to you guys again. Okay, maybe on the yesterday you guys maybe didn't join the session and you lost my sharing link. So sekarang saya share outside the link again. Give me a minute. Then I'll pergi cari. Saya ada image yang baru dan saya punya top of file. Kita tengah uploading. Ini topic of the VLAN hybrid. So duplicate some of the image files duplicate already. Tadi punya ialah VLAN routing. Okay now, so the drive, get the link. Yes, so select for everyone. Or post together and share it to check. Okay, see. So all the sharing file and also the topo file saya sudah masuk ke itu Google Drive. So you guys can actually download from there. I'm going to open the next topic. Okay, so for the next one, Intertran, iStack, and CSS. The objective, understand the function of link aggregations, understand the link aggregation type, the aggregation negotiation in the LACP. Ini yang macam tadi saya cakap punya link aggregation control protocol. Understand the advantage principle of iStack and CSS. The common application and networking of link aggregation and stacking technology. Okay, the content here. Network reliability requirements. So the network reliability refer to capability of ensuring non-stop network service when a single point or multi-point of failure occur on the device. Network reliability can be implemented at the card, device, or link level. So di sini you boleh nampak the high reliable network they perform the iStack. Okay, so that means the physical one is 2 switches, but you log in the moment, right? They only show 1 switch. Okay, so but these 2 is already aggregate. Okay, dua ini sudah combine become 1. So then for the switch itself, mereka nampakkan sebenarnya this switch connect to here, right? These two things is just one device, hanya satu saja. So kalau satu link ini sudah down kan, dia masih ada satu boleh keluar. Atau itu device sudah rasakan pun tak apa. Okay, because they still can use here to go out to the network B. So this is for the network high reliability. Okay, then the next is called the card reliability. Okay, so what is this? A module switch consists of the chassis, power module, fan module, main processing unit MPU, SFU, and LPU. This is the chassis. Okay, this is the chassis. Provide slot for various card and module to implement inter-card communication. The other banyak itu port. Tapi you nampak itu rack sangat besar kan? Sebenarnya this is also considered it's just one switch. Okay? Ini biasa di dalam service provider atau data center atau okay, this is just considered one switch. So semua yang ada di sini kan kita panggil LPU, line card. Okay, dia macam line card lah. SFU switching private, dia akan switching dengan Dia macam kita punya engine, character punya engine. So it's actually perform the switching. Okay, in between you punya card, in between you punya card. Then LPU you punya card. So macam ni kalau you ada satu interface, okay, ada satu port connecting with the cable, and then right here also have one. Kalau data masuk dari sini kan, dia hantar masuk ke sini. Dan nak keluar dari sini kan, okay, dia perlu switch di antara dua line card sini. Sebab dua line card ini tak sama card dia asing-asing ni. Satu di atas, satu di bawah. So macam mana mereka buat connection? So dia akan pakai backbone punya connections. So dia akan guna sini. Di sini. So that means your traffic you actually send to then go to another interface. So ini SFU sangat penting. Okay, I mean this one. Yeah. A bit laggy. So what I mean this one. SFU. So di sini traffic di dalam LPU kan. If let's say between the LPU kan, ia perlu lalui SFU. SFU ini akan tolongkan mereka buat itu switching antara LPU. Okay, so more SFU that got the switching capability kan, performance lagi bagus. Okay, so dia ada delay ini sangat laju. So this one can be avoid the switch to switch delay. Okay, sebab kan mengapa data center nak gunakan itu chassis sebab ia punya performance sangat laju. Kalau you compare ke dulu punya design okay, like this one okay, chassis versus the box switch. Okay, apa mereka punya difference? Ini ialah mereka okay, the difference between the chassis versus the box switch. Perlu draw kan. So switching fabric unit di tengah-tengah sini. Okay, so sebenarnya ini adalah satu switch ya. Okay, this is actually just one switch. So you boleh nampak mereka punya difference. If you go for the traditional switch ya, daripada switch satu kan, kalau nak hantarkan itu packet, itu frame pergi ke switch 7 kan, ia akan jadi macam tu. Ini ya traditional punya box switch. So satu switch hantar ke lain satu switch kan, dia tengokkan you punya port sini kan. If you are using the gigabit Ethernet port kan, you punya speed dia hati 1 gig. 1 gig daripada switch 1 pergi ke switch 4, switch 4 pergi ke switch 7. So you punya max speed hanya 1 gig. So you punya switching capability ya di sini. Dan bottleneck. Sudah ada itu bottleneck. Slow down. Tapi untuk chassis mengapa ia jual sangat mahal? Okay, mengapa data center mereka mesti nak pakai ini? Dia ada sebab ni. Satu LPU boleh gantikan satu switch. Okay, this one so one LPU is one switch. You boleh imagine, it's one switch. Now, one LPU, one switch. Ya, tak nampak. Okay, one LPU is one switch. Satu card macam tu, dia sudah ada 48 port. Banyak, only one card. Okay, tapi kan, daripada LPU satu kan, nak hantar paket pergi ke, for example, I send the data, I want to send to the LPU number 4. Okay, sebab dia dua card yang tak sama kan. So, dia nak hantar pergi ke sana. So, macam mana dia hantar? Okay, dia akan lalui ini. Ini kita panggil SFP. Switching Fabric Unit. So, ia punya speed boleh up to 480 switching capability. So, that means dari sini, LPU 1 pergi ke LPU 4, you punya speed up to 400 lebih. Sangat lajunya. Okay, so that's why data center dia boleh gunakan ini. Okay, dan ini benda sangat mahal. Okay, if I'm going to tell you the price, you are actually shocked. Okay, so the price for this one, okay, I just give roughly only, so it's around like 2K plus. Okay, per box. Okay, dia pun ada yang murah punya lah. So I just give the roughly pricing. Start from 1K plus. Tapi for chassis punya harga kan, okay, depend on the model lah. So saya sangat susah nak cakap lah. So 200K plus. Okay, I mean satu rack ini ya tak masuk card lagi. Okay. Okay, only chassis dia punya itu macam rack saja. Saya belum termasuk ikan setiap itu card. Setiap itu card pun lebih kurang ada around lah, roughly I put like 50,000. Setiap satu card. Okay, SFU belum tambah lagi, LPU ni belum tambah lagi. So kalau you total up semua benda ini sekurang-kurangnya ada $400,000. Okay, ini bukan itu rupiah. Okay, it's not a rupiah. This is the USD in the USD. So do you boleh imagine one chassis like this the complete set you sudah boleh beli bungalow. You can actually buy the maybe Bugatti this kind of yeah, correct. So that's why it's not cheap. A lot of the small network, right, they will actually prefer this one. Okay lah. So I don't want to spend the money to buy the chassis. I think this is actually good. I feel. Okay. So 1,000 is still okay to me. But for the data center and the ISP, tak boleh. Sebab dia ada banyak pelanggan. It's a lot of the customer, they will also want to enjoy the high speed. So yeah, they'll buy a lot of this one. Dia bukan beli satu saja. If you went to the data center before, you can saw their server room kan. Satu server room ada berapa ini? Kurang-kurang ada 10 atau 20. Okay, 10 or 20 set. So you can imagine in one server room, they got a few millions dollar of the equipment. Each of these chassis, they're equal to one of the sport car already, or maybe one bungalow. Yeah, so this is just like one of the idea for you guys. Tahu kan mereka punya difference. Okay, ini lah switch. Okay, nanti saya akan upload. So now you know mengapa itu device dia berjual sangat mahal. First, dia punya switching capability. Yang second, dia punya high availability. Okay, walaupun sini saya ada 4 SFU. Antara mana satu rosak kan, dia pun tak ganggu saya punya switching performance. Dia pun tak ada masalah. So, kalau saya punya fan rosak atau saya punya MPU, dia punya itu main processor, dia ada backupnya. Dekat atas ni. Satu main, satu backup. Main sudah mati kan, dia masih ada satu backup. So, chassis ini kan tak mungkin akan mati punya. Okay, there's a very very low downtime. Even you tell me impossible. How about for power? Kalau power sudah cut off, you sure no more redundant. They actually below here, they also have the battery. Okay, dia pun ada itu power punya. Tapi itu power kan, dia kasih banyak kan. You need to have the UPS to supply. Okay, biasa data center sudah belikan itu chassis tak mungkin mereka tak ada duit boleh belikan itu UPS punya. Okay, they already spend like 400 plus $1,000 to purchase the chassis. Impossible, they don't have the money to purchase a UPS. It's just like few $1,000. Okay, so yeah, America share ada itu power backup. Yeah, so this is all already that you know. So what is the LPU? What is the SFU? The Huawei punya brand pun sudah consider murah. Okay, for some other brand, Juniper, Cisco, I think it's even expensive you compare to the Huawei one. But performance-wise, right, more or less is the same. They don't have much difference. And the device reliability, no backup. If the aggregate switch faulty, the traffic from the downstream cannot be forward. Yeah, sebab single point saja, you dah ada backup. If you are doing the master and backup, okay, you sentiasa ada satu device yang aktif, satu yang backup kan, then you tak perlu risau tentang kan itu device punya masalah. Sebab kalau ini rosak, I still got one is a backup. Okay, then this is for the link reliability. So if I using one link, they only have single uplink. If one point failure, I will lose the connection. So some people will like to say, I will put the two link right here. In case one is faulty, I still have another as a backup. But ini kan mungkin ada loop. That's why you perlu enablekan LACP, okay, to preventkan loop dan enhancekan bandwidth. Okay, so that's why sekarang kan dia tunjukkan cara macam mana bagi aggregate kita punya link. Kasih kita punya link kan ada itu loop balancing. Okay, how to achieve? When the multiple link access between the device, the traffic is forward on only one link due to the STP. Okay, in this case, the inter-device link bandwidth remain unchanged. How? STP, spanning tree protocol. Okay, ini nanti saya akan cover. Okay, so dia cakap, kalau kita punya device sudah enable STP ya, semua interface ini akan block, hanya satu forward. So no matter how many port you are using, so end of the day ya, you hanya dapat satu port boleh forward data saja. Okay, inilah dia punya masalah. So kalau you nak semua port pun aktif kan, you mesti nak enable kan LACP to enhancekan dia punya bandwidth. Okay, so how to check? Okay, Ethernet link aggregation. Okay, ini nanti saya akan tunjuklah di saya punya ESP. Okay, I'll show how to do the configurations. Okay, let me see what the thing they're going to introduce. Yeah, I think I will straight away show you directly from the ENSP. Okay, I explain from my ENSP instead of following the slide here. Yeah, no worry. I will show you the demo. Okay, kita datang ke sini kan. I'm no longer using this one anymore. No more VLAN now. We will start with the new lab. Okay, kali ini kan kita nak keluarkan figure switch. Okay, just auto connect. Port 1, 2, 3. Okay, gunakan 3 interface. Okay, 2 to 3 also same. Okay, then bring it up. Okay, so it's already up. So I will show my configurations. Okay, this is not very hard. Get the command. Let me verify first. Look better is better. Trunk port. Okay, so this is my configurations. You boleh nampak sebenarnya sangat senang. Okay, you just have to configure one logical interface and then put those of the member port under the either trunk. That's all. Okay, itu saja. So you create satu logical interface, either trunk. Then you pilihkan mana satu ialah you punya port member. Port member saya gunakan port 1, 2, dan 3. Okay, so make sure you guys can actually done this one. Okay, it's pretty easy only. You just select the mode and then adding the port member. That's all. You can see the result. So boleh gunakan display either trunk followed by satu, sebab saya sini ada satu kan. Then checkkan you punya working mode. Working mode normal, that means you are running the manual mode. Okay, the manual mode is in the full active. So sekarang saya punya port member semua up. Okay, semua up. If you want to check the speed, what is the speed that you can get right now? Since these three port is already bundled together. So display interface either trunk. Okay, guna command ini. Okay, you menambah tiga interface ini ialah up. Okay, so scroll up. Okay, then you will notice this. So dia akan tunjukkan you punya maximum bandwidth. Maximum bandwidth ialah 3 gig. Then the current bandwidth yang sekarang pun 3 gig juga. Okay, so maximum dan current tak sama. Okay, so the current bandwidth ialah yang sekarang yang ada punya. So semua kabel kalau aktif kan tak ada masalah, you dapat 3 gig. Tapi if one of your interface down, you punya bandwidth akan kurang jadi 2 gig. But your maximum bandwidth is still the same. Okay, it's always show there's a 3 gig. Sebab saya ada di the port member. So dia tunjukkan you maximum. Okay, kasih you tahu sekarang ada berapa cable up, berapa cable is down. Okay, now my bandwidth is only 3 gig. Tapi 3 kabel ini sekarang sudah jadi satu. I mean the logical one. Between the switch 1 and switch 2, mereka ingat sekarang you and me, the connection is only one link. Just one link connection with the 3 gig. Okay, so kalau you boleh nampak ini, that means you sudah berjaya. 3 link sudah bundle jadi satu.
Okay, so if you guys have no problem, okay, then I'll proceed to the next one. Okay, so this is my other configurations. Okay, LACP. So the LACP I configured on the switch 2 and the switch 3. So I just want to show you that between 2 and 3 is running LACP, 1 and 2 is running the manual. So what's the main difference here? If you choose the manual mode is all inactive. It is full active. So kalau you ada 3 cable, you dapat 3 gig. If you got 2 cable, you got 2 gig. It's always the full bandwidth. Tapi kalau you gunakan LACP kan, you boleh support dual mode. Mode yang pertama full active. Mode yang kedua active dan backup. So you boleh pilih berapa link active, berapa link backup. Okay, so that's a LACP. Only LACP boleh pilih mana satu interface jadi backup dan how many backup. So, kali ini switch 2 display either trunk dua. Sebab ini dua, di saya punya switch to 2. So, saya tengok di sini kan, kali ini tak sama lagi ya. Dia tunjuk working mode ialah static. So, static di Huawei sini sebenarnya ialah LACP. Okay, is a LACP. Okay, then what they say, all my interface is selected. Selected mean ya pilih lah active-nya. Okay, is active. So now display interface either trunk. Okay, saya nak tengok ia punya speed. So what is that? Maximum bandwidth and my current bandwidth is also 3. Hey, sama dengan yang manual punya. Okay, so it's no difference. There's further proof the LACP dia ada dua mode, manual dan LACP. Manual ialah macam static, okay? Tapi kan dia tak jalankan dynamic routing protocol. They don't have a dynamic protocol, sorry. Okay, but if you're running the LACP, you will actually practically send the LACP protocol to discover and maintain the neighbor relationship. Okay, hanya LACP dia akan keep hantarkan LACP. Maybe I try to show you in my workshop. Tapi saya perlu tangkap semua interface kalau macam tu. Okay, port. Okay, saya capture port number 1, port number 2, port number 3. Okay, 1, 2, 3. Semua port saya pun pergi capturekan dia gunakan workshop. Okay, so this is my port number 1. Do you saw that? The port number 1 is empty. Nothing appear. Okay, number 2 here, you only see that got the STP. Tapi ini bukan LACP ya. STP ialah protocol yang lain. Okay, bukan LACP. So I also can say that this is the empty also. Then number 3, empty. So that means if you are running the manual mode, they don't send any dynamic protocol. Okay, you just keep as a silent. But they know this 3 port is already bundled together, become one either trunk. Okay, ada 3 bandwidth, 3 gig bandwidth. Okay, then for here, tempat lain sini kan, saya cuba tangkapkan port 1, 2, 3. Okay, this network right here. Let's see what's the difference. Sini, pemula dari sini. Okay, you boleh nampak, ia ada itu wording panggil LACP. Ia running dynamic protocol. Because ini sangat penting. Mereka nak tahu siapa ialah dia punya neighbor. Okay, then kedua, ini pun ada juga. Nampak tak? Ada LACP. Okay, LACP keluar. This is the dynamic protocol. Okay, and the last. Yeah, ada juga LACP. So ini akan berlaku kalau you gunakan LACP mode. Okay, so they're running the dynamic protocol to discover the parameter. Okay, so now what if I want to run the active and the backup for the LACP? Then how to do? Okay, first, kalau kan sekarang you nak buat active dan backup, so you boleh pick, okay, you cakap, I don't want all in the active mode. I want 2 active, 1 backup. Boleh tak? Okay, so now you have to go to the switch tree here. I pilih switch 3 jadi master. Okay, so go to the system view. You just put LACP parity 0. Okay. Okay. So LCP priority is 0. The priority here is who got the smallest priority value, you will actually elect to become the master. So the smallest is the most preferred. So sekarang I gunakan switch 3 kan jadikan master. So that's why saya letak kosong. Kosong ialah paling kecil sekali. So now since the switch 3 become the master kan, okay, sekarang saya boleh ubahkan sikit setting. Okay, go to the switch 3. Interface Intertran. Masuk balik ke itu Intertran. Now, I am in the Intertran view. Okay, di dalam sana. So you put max active link number. You nak berapa active? Sekarang saya ada 3 port kan. So saya hanya perlu 2 active. Satu ialah backup. So then ini adalah cara dia. Okay, maximum active link number. Okay, now you boleh cuba display ya. Display Intertran 1 switch 3. You tekan saja kan, sekarang you boleh nampak. Saya sekarang punya maximum active link number yang 2 saja. Tapi I ada 3 port member dan satu sudah jadi unselect. Okay, sebab ini yang extra punya. Saya hanya kasih 2 active. So port 1 dan port 2 ialah active. Port 3 akan jadi backup. Sekarang berapa bandwidth I dapat? Display interface Intertran 1. Enter. Okay, you nampak satu sudah jadi backup. That's why dia tunjuk down. So scroll up. You boleh nampak. Maximum bandwidth still is the 3 gig, but my current bandwidth changed to the 2 gig. Sebab saya pilih 2 active, 1 backup. That's why my speed sekarang is only 2 gig. Okay, ini adalah satu cara pergi ubahkan you punya maximum active link. Okay, you can actually choose how many active, how many backup. Only the LACP mode boleh support. If you do the manual, ya tak boleh ya. Okay, sekarang number 3 sudah jadi backup. What if I want the port number 1 become the backup? Is that possible? Okay, so first you perlu faham mengapa adalah sebab mereka punya port ID 1, 2 dan 3. Sesiapa gunakan port ID yang paling besar, ia akan jadi backup. Yang kecil punya boleh forward. Okay, then the port semakin besar, then which is have a very low priority. So sekarang tak mungkin you boleh tukarkan itu port kan. Port memang sudah fix punya. Tapi you nak pilih port nombor 1 jadi backup. Then how? You need to change the priority. Change the port priority. So the port priority right here is 32768. Ini ialah system default. Okay, so semakin besar punya port priority kan, then ia akan jadi backup. So they normally don't prefer the big value. They only prefer the small value. So if the port 1, you need to make it become the backup. Okay, follow this step. Okay, LCP priority. Sebab saya tahu kan, port priority ialah 3, 2, 7, 6, 8. Okay, you hanya nak masukkan itu priority value lagi besar daripada. Okay, daripada yang asalnya. Dan ini port akan jadi backup. Macam ni lah. So this is what I did. tapi belum habis lagi ya, belum habis. Kita baru tukarkan itu port punya priority kan. Dan you still have to do this. Okay, enable the preemption. The preempt enable and set the delay timer is 10 seconds. Okay, because I want to see the fast result. Sebab kalau tak ada enable dengan preemption kan, nanti ya, you sudah tukarkan dia punya parameter, some of the setting, it won't make the change. Okay, dia akan apply dia. So until that your active is down, then the packet will be actually take the effect, but it will going to take very long. So that's why I show this one. Okay, ini kita hanya perlu buat di dalam master punya LCP. You nampak tak? Di I punya switch 2, switch 2 right, I actually don't do much configuration. I only configure the port member and select the modes. That's all. And switch 3 right, I will do a lot of changes. Okay, switch 3 I set the priority 0 because I want to make it become the master. Then port priority, this interface, the priority 40,000 is very low priority. Then the port member, maximum active link is only 2. I kasih 2 jadi active, boleh forward data. Yang tinggal punya ialah backup. Okay, then preemption. Okay, so you can see this is the only configuration for LCP. Sebenarnya pun tak sangat susah. Okay, after you already done this configuration, kalau dah kan, switch 3. Display either trunk 1. Okay, chat. So you boleh nampak, sekarang pos 1 sudah jadi unselect. Dia unselect. Dia jadi backup sekarang. Yang bagi satu punya itu timer, preempt delay time is 10. Okay, I hope all of you can manage to do this one. Sebenarnya pun tak sangat susah punya. Okay, and this is one of the very common use technology. Okay, you should actually learn this one. No matter it's the big network or the small network, we still also need this. ACP. LACP, this one. Okay, you guys try to do this one first. Okay, I'm going to upload this to the drive. Okay, I upload my this top up file to my drive. Okay, I just updated the driver. Okay, so I will put the add-on here, manual versus dengan yang LCP punya. Okay, so I'm doing this summary for you to compare these two differences. So the LACP versus the manual mode. So if you're using the manual mode, okay, it's supported by all the product, all the vendor. And the benefit right here is, especially when you have a lot of the different brand, okay, they have the HPE, the Cisco, Huawei. So those brands you actually mix together. So when you are using the Cisco connect with the Huawei, so you better don't using the LACP. It might not compatible. So in this case, you can consider using the manual mode. Okay, because manual mode, they don't running any detection protocol. So for them to set up the Intertran is very easy. Okay, so that's the manual mode. So no dynamic protocol. This is the advantage right here. Sebab dia tak share any protocol punya. So dia boleh tolong reducekan kita punya itu flooding traffic di flat network, layer 2 punya network. So manual mode dia boleh support full active. Okay, full active. Semua link pun active punya. Kalau nak gunakan active and backup, you have to use LACP. So the LACP might not compatible with other vendor product. So ini tak ada guarantee punya. So pun ada orang Huawei, some of the brand boleh compatible dengan Cisco punya. Tapi of course it's not all the model. Okay, some model only. So no guarantee. Then send LACP protocol to maintain the connection and control. Mengapa dia nak send dynamic protocol? Sebab mereka nak negotiatekan parameter. Dia nak tahu who is a master. Now, how many port is the active? Which port I need to be made become the backup? What is your priority? So the other banyak benda nak pergi compare. So that's why they'll keep sending the LACP to do the discovery. LACP boleh support full active mode dan juga flooding mode. That means active and backup lah. So you boleh pilih berapa active, berapa backup. Okay, up to you. Okay, you're just using a priority to adjust. Then the last one, ini dia punya key point, can discover by the NMS. Sekarang kita punya network always monitor by the software. So itu software dia boleh tunjuk di you punya big screen, and then you can monitor all the link condition. Mana satu link down, mana satu link out. If you are running the LACP, you boleh dapat discover daripada NMS. So dia boleh faham. Sekarang you punya switch ada gunakan LACP. Dia sudah jadi satu link. Okay, satu link dengan 3 gig punya bandwidth. Kalau you pakaikan manual mode kan, itu manual mode dia tak dapat discover daripada NMS punya. Dia tak tahu. Dia ingat kan, sekarang you ada 2 switch connect dengan 3 physical punya cable. That's all. Tapi adakah ini running ke LACP kan? Dia tak perasan punya. Okay, berapa speed yang you ada, dia pun tak boleh kasih tahu. So that's why a lot of the network, they would like to using LACP. Okay, they got the reason one. Okay, so this is the the comparison between the LACP versus the manual. Okay, so this will be all that I want to cover for the link aggregations. So after the lunch break, we come back. Then I'm going to show you the spanning tree protocol. Okay, the spanning tree protocol is also very important. A lot of network that are actually running this. So, but the theory is actually quite complicated. Okay, so that one I will go through it after we come back from the lunch. Okay, so akan tunjuk. So remember itu timer. Okay, so saya sudah set itu timer. Bagi punya discussion ialah sekarang we actually get ready for pray, pergi sembahyang, and we're going to return the training at 2. Okay, so I'll put the note here, okay, in case you guys forget. Yeah, change it to 2. So you have enough time for you to go out for lunch. So remember, come back at 2.